Welcome back, Algebra class. We are going over Elementary Algebra by Jacobs, Chapter 12, Lesson 3. And we're going to begin with an equation in standard form, specifically a linear equation in standard form. So if you've been paying attention to the last lessons, you should hopefully know that an equation in standard form is going to be written like in descending order of power from left to right, and set up so that it equals 0. So 2x plus 4 equals 0 is in standard form because the highest power is x to the power of 1, and then the next one is actually x to the power of 0 if you want to think of it that way. And so we call this a first degree or linear equation. Because if you have a first degree equation, meaning one where the highest polynomial's degree is 1, like this, then it's going to be graphed as a straight line. Now, you could take this exact same equation and solve it two ways. Number one is the conventional way. I get it out of its standard form in order to isolate x, and so then what I would do is this. 2x plus 4 equals 0, minus 4 minus 4. 2x equals negative 4. 2x divided by 2 equals negative 4 divided by 2. X equals negative 2. That's barely visible down there, but that says x equals negative 2. Maybe I'll do that. All right. Now that would be solving it the conventional way, but we can also solve this by graphing. And you might be asking yourself, wait a second, how on earth could I solve this by graphing? For graphing, don't I need an x and a y value? Yes, you do. But you may recall that the setup for graphing a linear equation is very similar to standard form. If I say y equals 2x plus 4, what I've done is I've taken this equation, which has one answer, and I've basically taken that equation and turned it into a function that can have an infinite number of answers. So all I did to do that is I replaced the 0 with the y. And for convenience sake, I moved it over because you can do that with equal signs. So then you might be thinking, all right, I'm confused. You said that you can solve this equation by graphing it, but to graph it, you need a y value. And when you put in the y value, what you do is you create an infinite number of possible x and y values. In other words, an infinite number of possible answers. But if you want to solve this, in order to figure out like what value of x do you want, you just actually choose the value of x that crosses the y-axis. In other words, the x-intercept will be the answer to this problem. So we know the answer to this problem is negative 2. And we're going to say negative 2, 0, because that's going to be negative 2 on the x-axis and 0 on the y-axis. There is no y in this, so it makes sense that we would say y is 0, because if y were 0, we could add it anywhere that we want to, and it's not going to affect anything. So if you're getting confused, hopefully this example will straighten it out. I'm going to graph y equals 2x plus 4. So what's my y-intercept? That's going to be whatever if I make the value of x 0, the y becomes. In other words, it's the point where I cross the y-axis. So if x equals 0, y equals 4. 2 times 0 is 0, plus 4 is 4. So that's just starting me out. That's not really going to find the answer. But if I made y equal 0, meaning I need to ask myself what value of x is going to, when added to 4, equal 0, then I know that negative 2 will. Because negative 2 times 2 equals negative 4. Negative 4 plus 4, or I'm sorry, it's going to end up equaling 0, because 2 times negative 2 is negative 4, plus 4 equals 0. So that gives me then the coordinate -2, 0. And I could create a line out of this equation, but my answer to my original equation, 2x plus 4 equals 0, the answer is going to be -2, 0, and I'm not interested in the y value of 0. It's actually just going to be the answer is -2. So that may have sounded rather complicated, and I suppose it was. But what can we say in recap to sum it up? If you've got an equation in standard form like 2x plus 4 equals 0, then you can find the answer conventionally, or you can actually graph it and just figure out where that equation, if you replaced the 0 with a y, is going to cross the y axis, because wherever it crosses the y-axis, y actually is 0. So by solving for y, you're solving for 0, which is the original equation. Now, that's something that you get to do with any standard form equation. Maybe I'll do one more. I'm just going to make it up. Something easy. (10x plus 10 equals 0). Make it even easier. (-10 equals 0). All right, so let's say that we want to solve this the conventional way. We're going to add 10 to both sides to isolate x. 10x equals 10. Divide by 10, divide by 10. Probably guessed this from the beginning, but x equals 1. Can we solve this by graphing? Sure. But instead of saying 10x minus 10 equals 0, we're going to say 10x minus 10 equals y, or to put it in a more comfortable format, y equals 10x minus 10. And if I were to plot some points, I'm only really going to need to plot one. But I'll go ahead and draw that anyway, just out of sheer habit. If x equals 1, y will equal 0. But I'll do a second point anyway. Let's say x equals 2. So if x equaled 2, 10 times x is going to be 20 minus 10. So but then if I have x equals 1, 10 times 1 is 10, minus 10, y will equal 0. And so I wanted to have 2 points so I could make a line, because you only need 2 points to create a line. And if 10x minus 10 equals 0, and the point where your graph crosses the y-axis is where y equals 0, then 10x minus 10 equals 0 is exactly the same thing as 10x minus 10 equals y, and therefore you can graph for y and just choose the coordinate that's going to give you 0, and you're solving for this equation by graphing. Now that whole almost 9-minute explanation was really just to prove one thing, which is that for an equation, you can find the solution simply by finding where the x value at the x-intercept and the point where y equals 0. Now, what if we did this with a quadratic equation? You may recall from last lesson that when I draw a quadratic equation, I'm going to be making a parabola. So in this parabola, how many times do I cross the x axis? Once here, and once here. So I'm going to have 2 potential answers to every quadratic equation. And this is because if I have something like this, x squared plus 4 equals 0, put it in standard form, subtract 4 on both sides, x squared equals -4. shoot, I did that wrong. X squared minus 4 equals 0. Add 4 to both sides, and then x squared equals 4. Then if x squared equals 4, I need to isolate x by doing this. Find the square root of both sides of the equation. So the square root of x squared is x, and the square root of 4 is 2, right? But this is the one time in algebra, at least in the scope of Algebra 1 in this book that I know of, where you actually need to give your answer to the square root as a plus and a minus. So if I were to graph this equation, it's not going to look quite like that one. I'll prove this to you. Instead of x squared minus 4 equals 0, we're going to say x squared minus 4 equals y, or for convenience sake, y equals x squared minus 4. And we'll just graph, let's just have fun with it, graph a few different coordinates. We'll make sure that 2 and negative 2 are in there. We'll say 0, 1, negative 1, 2, negative 2. All right, so y equals x squared minus 4. If it's 0, 0 squared minus 4, y is going to be negative 4. So our y-intercept is negative 4. If x equals 1, 1 squared is 1, minus 4, y would equal negative 3. So x is 1, y is negative 3. All right, x is negative 1. What's negative 1 squared? That's positive 1. Minus 4. So y is still negative 3. Mirror image. We found the center point of our parabola. Now, what about 2? That would give us 2 squared, which is 4. Minus 4 is 0. And there we are. We have our x-intercept. So one of the x-intercepts, this by the way is, this is going to be x value 2, y value 0. And that can be an answer to the equation because that gives us a non-existent y. And since the equation doesn't have a y to begin with, it was originally x squared minus 4 equals 0, then that's going to be our acceptable answer. But what about negative 2? If I have negative 2, remember you always put your x values in parentheses. Then negative 2 squared is 4. Still 0. So I've got a nice little parabola there, bilaterally symmetrical, mirror image in other words, and I have two possible answers because I have two x-intercepts. The two x-intercepts are negative 2, 0 and positive 2, 0. And if I plugged those x values, because I don't need y equals 0, because there is no y in here, if I plug either of those x values into here, it'll produce a true statement. So x as 2 squared minus 4 equals 0. 2 squared is 4, minus 4 is 0. So yeah, that's a true statement. What about negative 2? Negative 2 squared, negative 2 times negative 2 is going to be positive 4, minus 4 is 0. So yes, both of these will work. They're both true answers. And we can prove that by solving it regularly, but we can also find it really quickly by graphing. And so, how would you write your answer to this problem? I'll do it again, because this is a little bit of a new symbol. X equals plus or minus 2. That's a plus sign resting on top of a minus sign, not connected, so really resting over, equals 2. And so that's how you're going to write your answers to quadratic equations. You're going to say plus or minus whatever the answer is. Believe it or not, I think that fully pretty much prepared you for the homework. There's not a ton more you need to do in the homework than what we just did in this lesson. But note to self, they're going to give you a whole bunch of equations, and they'll say, what is the answer? Just based on looking at this line. Like if this is the graph of an equation, what is the answer? The answer is going to be the x value of whenever it intersects the x-axis. So that's going to be x equals something, let's just say -3, 0. So the answer to this equation would be -3. Now I don't think you have to know this for the homework, but what type of equation is this? This would be a linear equation. They'll also give you some like this. And let's say this is the point -5, 0. That would be one of the answers. And the other one would be +5, 0. Those would be the two answers to this equation, and it is going to be a quadratic equation. Note to self, your x values on these equations, they will not be exactly the same, like x equals -5 and x equals 5, if the equation has additional clutter in it. If I had, for example, x squared, like, I don't know, plus 3x equals 0. Here's a fun fact that I haven't encountered in the book yet, and I doubt that they're going to tell you this. Let's just do x squared equals 0. When graphing this, you would translate that into y equals x squared and graph that. And the graph of that we've done before is going to be roughly like this. And that one actually, I guess it would only have one answer because the x and y axis are both 0. So yeah, the only way for this to be true is if x equals 0, and there's no mirror image of that one. But, so let me do a slightly different one. Let's say x squared minus 2. Whenever you add a constant like that, you're shifting downward. So it's going to be exactly the same shape, but -2. And if it had been +2, you'd be shifting upward. So here you would have two different answers, one there and one there, and they would be exact mirror images of each other. So if x squared, let's see. So the answer to this one then, so yeah, that one's going to be kind of a funny one. Let's say it was, okay, never mind. I'm not going to micromanage that. I'm just going to leave it there. I'm not going to go into what the answers are. But you would need this to equal 2. So this would be the square root of 2 is the answer. So it wouldn't be a very nice and neat one. It would be one that would make sense, but it's just not very nice and neat. Anyway, I digress. So if I have the same equation, like x squared, I don't know, let's just say -2 equals 0, but then I throw in something else like x squared, well, how about this? X squared minus 4 equals 0. This will be easy to work with. All right, so of course, 2 squared is going to be 4, and so is -2 squared. So our answer then, we have a y-intercept of -4. I'm teaching you to do more than is in the book here. I'm showing you how you can manipulate these graphs. That's our y-intercept, and then our x-intercept is going to be x equals 2 and -2. And our parabola is going to look like that. Because if I have 2 squared minus 4, that does equal 0. If I have -2 squared, that's 4, and minus 4, that does also equal 0. But if I have something like this, x squared plus x minus 4 equals 0, what that's actually going to do, that plus x, fun fact, you don't need to know this, that's going to shift the entire parabola one space to the left. So this second one is going to look like this. Everything's the same, except it's shifted left 1. So instead of, let's see, instead of positive 2 and negative 2 being the answers, it would then become negative 3 and positive 1, which we could figure out by looking at this equation. For example, 2 squared. Well, let's do the answers. Hold on a second. So I worked it out a little bit more. So I was wrong that the answers, the x values that would answer the equation would just shift over to the left by an even amount. But I did prove what I guess I did remember correctly, but thought it contained the other information I said, which was incorrect. That when you add like an x value, you're going to be shifting your parabola to the left for a quadratic equation. If you added like a negative x value, you'd be shifting it to the right. And so, anyway, that was just a fun fact. If it threw you off, then just forget the last couple minutes of the video. But it is interesting to know, like, if you have, like, for a quadratic equation, you got something like this. If you want the entire thing to move down, then you just subtract, you know, a greater value, and then this would shift down by that much. If you want it to move up, then you add a certain value and then move it up. And if you wanted to go left or right, then what you do is to go left, you add like this would shift it left. And then if you want to go right, do like a -8, and that shifts it right. So it's kind of interesting. I'll go over the last one in the problem set. And again, this is set 3, so it's not exactly the same numbers, but it gives you an equation like this one, like y equals x squared minus 8x plus 10, and they've graphed it for you. And then they're going to ask you a series of questions about it. So, the first thing they say is between what integers are the solutions of, well, it says it has 2 solutions. One of them is between 1 and 2, because here's 1, here's 2, and you don't know exactly what this solution is, but wherever it crosses the x-axis, that's going to be your solution, because that's where y equals 0. So the solution to this one is going to be, the answers are going to be somewhere between, I guess you could say like, maybe like this one. X is greater than 1 and it's less than 2. You don't have to write your answer that way, I'm just trying to express it, but it's between 1 and 2. And then over here, it's somewhere between 1, 2, 3, 4, 5, 6, 7. It's either that or, well, it's, I guess it could be that and somewhere between 6 and 7. So they might give you some things where you know, you have to figure out what kind of ranges the answer is in just by visualizing it. They'll tell you that as an example, and then they'll say, between what integers are the solutions of the following equations? Refer to your graphs for exercise 12 to find out. So they'll give you some equations that you've already graphed, and you're going to have just some points where you don't know exactly what it is, but you know it's between 1 and 2, or you know it's between 6 and 7, or something like that. So you just have to write down that those are the answers. So I think that pretty much sums it up for this lesson, and hopefully that was helpful. I will keep these coming. Thank you very much.